By the end of this video, you should be able to describe the basic properties of each physical state of matter, define and give examples of atoms and molecules, classify matter as an element, compound, heterogeneous mixture, or homogeneous mixture, and apply the law of conservation of matter. The three basic states of matter that we study are solids, liquids, and gases. Solids have a definite shape and volume. Liquids have a definite volume, but they take the shape of whatever container they're put in, and gases will take the shape and volume of each of the containers that you place them in. The fourth state of matter is plasma. Plasma is a gaseous state of matter that contains large quantities of charged particles. This is actually the most abundant form of matter in the universe. However, we don't tend to deal with it too much in chemistry, at least not in the level of chemistry that we're doing. The law of conservation of matter states that there is no change in the total quantity of matter when it undergoes a chemical or a physical change. However, there often appears to be a change if we're doing a reaction or a physical change in an open system. If something is reacting with a gas or turning into a gas, then often we're either gaining or losing mass that we didn't actually take into account, either at the beginning or the end of the experiment. However, if we have a closed system where no matter is entering or leaving the system, then we will always see conservation of matter. An atom is the smallest particle of an element that has properties of that element and can enter into a chemical combination. A molecule is made up of two or more atoms joined by covalent bonding. And a molecule does have to specifically be covalent bonding. Some elements in their natural form come as molecules. For example, the diatomics that we learned last year, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, come as two atoms bonded together to form a molecule, even though they're still elements because it's the same type of atom bonded to itself. Two others that we'll be looking at this year are phosphorus, which comes as 4 atoms bonded together, and sulfur, which often comes as 8 atoms bonded together. So all of matter can be classified as either a mixture or a pure substance. By definition, a pure substance has constant properties and composition. Every sample of a pure substance you take, regardless of where it comes from or what sample size you have, the properties and composition are always going to be constant. A mixture, the properties and composition can change from one sample to another. If that pure substance can be broken down chemically, then it's a compound. If it can't be broken down chemically, then it's an element. Mixtures can be uniform throughout, or we could have different portions to it. So for example, chicken noodle soup has different things in it that you can see. It's not a uniform composition. So if it is a uniform composition, then it is a homogeneous mixture. If it is not a uniform composition, then it is a heterogeneous mixture.